Okay, so we're on to the last part of writing chemical formulas and naming compounds. We'll have a special category for compounds, which we call the acid compounds. And because they have a different mechanism for writing chemical formulas and naming them, that's why we need to have a separate discussion for this. Acid compounds behave like ionic compounds. When you write its chemical formula, then you just have to do the crisscrossing. But we need to organize our discussion for acid compounds into two. We have binary, so again, there are two elements involved in that. And if we mean ternary acid compounds, you have more than two types of elements involved. So let's go to the basic definition of acids. What are really acids? Let's just go over our Arrhenius definition of an acid because there are a lot of definition for acids. For the sake of writing and naming acid compounds, we'll use the definition of Arrhenius, in which acids are compounds that break up when you dissolve it in water to give off what we call the hydronium ions. Those are your H plus ions. A very common example of an Arrhenius acid is the hydrochloric acid HCl. So when you put HCl, put it in water, HCl will split up into two. We have H plus cation, which is your hydronium, and the other one is Cl negative, which is your anion. This is your chloride ion. So for the sake of this discussion, our chemical formulas for acids will always start with hydrogen. So if it begins with hydrogen and then you will see a subscript AQ, that means aqueous, that means it's dissolved in water, then you're dealing with acids. So you have to follow the rule in naming our acids. How do we name them? So how do we name acid compounds? So there are three categories for our sake. So we said there are two, binary and ternary. Let's have the binary first. So binary means you have hydrogen plus a halogen. Halogens are the elements found on group 7A in the periodic table. They have 7 valence electrons. Example is the common acid that I gave about for Arrhenius definition. So we have HCl. So binary because one hydrogen and one halogen, a total of two elements. So that's why it belongs to the binary category. Very easy. If it's binary acid, just like this, all you need to do is remember this method. Use the prefix hydro, then the XXX represents the name of your nonmetal, and then you let it end in IC and then space, then the word acid. So hydro blank ic acid. So in this example, since it's chlorine, chlorine will be inserted here in the XXX. So therefore the name is hydrochloric acid. You already make your chlorine and in ic. So chlorine will become chloric. So hydrochloric acid. So always remember that hydro, the prefix hydro, is only applicable for binary acids. Again, binary is you only have two elements. One of that is hydrogen, the other one is a halogen. So two elements all in all. Let's now go to the second category, our ternary acids. The ternary acids are subdivided into two. So when we say ternary acids, we have hydrogen plus a polyatomic ion. Ternary again involves hydrogen paired with polyatomic ion. Now you're familiar with the polyatomic ions. These are the ions listed in your list, and these ions compose of more than one type of element. So there are two different kinds of polyatomic ion that's going to be bonded to hydrogen. It can be a polyatomic ion that ends in 8 like nitrate, phosphate, sulfate, carbonate. So if it ends in ATE, that means it belongs to the category of an ic ending for the naming. So, for example, we have HNO3. HNO3 is written as this because H is a plus, NO3 in your list, if you look at it, has a charge of -1. So, crisscross 1 and 1, the generated chemical formula is HNO3. HNO3 because NO3's name is ending in ATE. That means I just need to change it to ic with no hydro prefix. No hydro prefix. So just change ATE ending to ic. So nitrate becomes nitric acid. Okay, that's simple. No prefix hydro. Remember the hydro was for binary. So if it's just ternary and it ends in the, if the polyatomic ion ends in ATE, change it to ic plus the word acid. Second category of polyatomic ion for ternary acids. There's a possibility that your hydrogen is paired with a polyatomic ion that ends in ITE, such as nitrite, sulfite, phosphite. These are examples of your polyatomic ions that end in ITE. So if it happens that your acid, your polyatomic ion ends in ITE, just change it to OUS ending, OUS. Now there's a mistake here, sorry, this is supposed to be HNO2. This is 2. Just change it to 2. So NO2 negative is a nitrite, it's a nitrite, then H is a plus. So the resulting chemical formula is HNO2. This is supposed to be 2. So the nitrite, the ITE, just change it to OUS ending. So nitrite becomes nitrous acid. So nitrous is the ending if your polyatomic ion's name is ITE. So let's have this as our conclusion to this. So if your hydrogen is paired with a halogen with another element, then it's obvious that you're dealing with binary acids. So if it's binary, always remember the prefix hydro and the ic ending to the nonmetal and then the word acid. So HCl was our example. It's going to become hydrochloric acid. And if for the second category of ternary acids, if your polyatomic ion ends in 8, such as these two examples, perchlorate and chlorate, add H plus to it, when you crisscross the oxidation number, perchlorate and H plus will become HClO4, change the ATE of perchlorate to ic and then add the word acid. So HClO4 is named as perchloric acid. For the second example, we have chlorate with a chemical formula of ClO3 negative. Add H plus, you crisscross the 2, you get HClO3. Because it's chlorate, ATE should be changed to IC, so the name is chloric acid. Last example for ternary acid category, if your polyatomic ion ends in ITE, such as chlorite and hypochlorite, all ends in ITE. So ClO2 negative, add your H plus, you crisscross the 2, you get HClO2, which is named as OUS ending. So chlorite becomes chlorous acid. Similarly, for hypochlorite, this chemical formula of hypochlorite, you add H plus. Remember, H should always be the first because it's the cation. So it becomes hypochlorous acid. And the when you crisscross it, the chemical formula is seen as that. So H and the other ion. Okay, so that's how you name acid compounds. Always remember, take note if it's binary or ternary, and you'll know what to do. Thank you. I hope you had a learning time. Thank you.